methods for assigning IP addresses to the host on your network. First of all is the static method or manual method, where you actually go to the host itself, log on either through a command line interface or some kind of web access, get access to the graphical user interface, and just assign the IP address and the subnet mask, and sometimes what's called a default gateway, which is the next hop router that you're connected to, and statically assign that. You can also do it dynamically, and the main way that we dynamically assign this is by using a service application called DHCP, Dynamic Host Configuration Protocol, where you create a scope of IP addresses, and basically you assign IP addresses from that scope to particular hosts, and the service does it for you automatically. The client station contacts the DHCP server, and it gets the IP address, subnet mask, gateway information, and a lot of other information as well. Or we can use what's called API-PA, which is the Microsoft term for RFC 3330. This is automatic private IP addressing, and it's basically kind of a failback solution. If your DHCP server is down or you've not properly statically assigned an IP address, it'll go ahead and give your workstation, server, or laptop a temporary IP address from a range of 169.254.0.1 through 169.254.255.254. And the reason why it goes ahead and assigns a temporary IP address from this range, which by the way is not a publicly usable address, is because some workstations and some laptops and PCs need to have their network stack configured and up and running before you can even get into the operating system and do anything. So it doesn't shut you out of the machine because network services aren't operating, especially in dial-up solutions and things like that. So it gives you the ability to kind of fall back on a IP address that kind of places you in a simple, what we call peer-to-peer network. You don't really have any public connectivity, but it does allow you to get your machine up and running till you can figure out what your DHCP problem was, or you can go in and statically assign a proper IP address to that particular host. If I go to the control panel of my Windows XP machine, I go to the network connections area, I'm going to right click on my network interface card and go to properties, and I scroll down here and I find the Internet Protocol. I can double click on that or choose properties. You can see that right now I'm obtaining an IP address automatically. In other words, a DHCP server has assigned my IP address to my machine. If the DHCP server has a problem or it goes down, then Microsoft's API-PA is going to kick in, and I'll get one of those addresses. Just remember, if I get an API-PA address, I can only talk to other computers that are on that same API-PA network, and the chances are I may be the only one. Or I can use the following address, and this is what we call static assignment, where you type in an IP address, 192.168.101.45. We'll use the example address. I could use the subnet mask, or if I'm in that situation from earlier where I have subnetworks created, I would use the mask 192, and then the default gateway is simply the router that this particular machine is connected to. And if you go back to that diagram that we saw earlier with the 4 networks, it would be the IP address assigned to the interface on that particular router. Typically, this workstation will be connected to a hub or a switch, which then is connected to a router that has a valid IP address on this same network. So that's a static or manual configuration. Before we leave this nugget, I got to tell you that the future is here. IP version 6 is already being put in place to replace IP version 4. IP version 6, also known as IPNG for IP Next Generation. It greatly expands the address space. It enhances the security of your IP addressing, and it improves quality of service over IP version 4. Bottom line, with quality of service, you can just do a whole lot more with that particular IPv6 address. There's a lot more space, a lot more fields to control and manage how that particular address is used and moved. It's governed by the Internet Task Force, IETF. The IP version 6 address space is 128 bits, so it's huge. It's a huge number. 340 undecillion, whatever. It's just a gigantic number. 340 undecillion. IP version 4, the 32-bit address space, is about 4 billion numbers, which sounds like a lot, and it seemed like a lot to the founders of the internet too, but think about it. China, India, South America, well, you do the math. 4 billion, not going to cut it. So we've got IP version 6 with its 128-bit address that's expressed in a hexadecimal format. Here's an example of what an IPv6 address would look like. This is really the basic information for the exam, but if you want to dive deeper into IP version 6 and look at all the ins and outs and nitty-gritty, here's a great website for a tutorial for IP version 6. You can jot this down and go check out this PDF file, this Adobe Acrobat file, and download it and get this little 8-page document that goes into much greater detail about IP version 6. All right, that's IP addressing for your Network Plus exam. A lot of math, a lot of numbers, but you did a great job. You're now a binary person. Zeros and ones, baby. We'll see you in the next nugget. In this nugget, we conquered 6 key knowledge areas. First of all, the overall structure of the IP version 4 address, the different address classes focusing on Class A, Class B, and Class C. Then, the private or reserved address space within those classes, looked at the reasons for using IP subnetting and how it's done. Then we looked at address assignment methods, 3 main methods: static, DHCP, or automatic, and API PA. And then finally, IP version 6. I hope this CBT nugget's been informative for you. I want to thank you for viewing.